Hi, I am Raghu. Today in this video, I am going to show you how to build a crash ball game and car game using Edge RTX 7. So first I will show you how to build a project in Vivado software. So now let's get started. So now this is the Vivado software. Now I will show you how to create a project. So here you can find create project, click on it, then next. And here the name is project 3, so I am leaving it as is. Next. Now here you should select RTL project and tick this. Do not specify sources at this time. And then go to next. Now here you should select the part of the board. I am using RTX 7. So I am selecting this part. Now select this and next. Now here you should finish new project summary. Now the project is getting created. So here you can see the project is created almost. So this is my project summary. Here you can see my project is created named car dodging game. Now I'll show you the design sources of the project. So the first one is car dodging game, which is known as the top module of the game. This module is used to ensure that the car and road parameters are perfect in the game. It makes sure that the button pulses are blocked until the next frame so that the button reactions are not missed during playing the game. And it also connects the game logic, enemy logic, collision score, conversion, and VGA rendering. Here you can see the local parameters of the road, lane, car, player, etc. of all the parameters in this code. Here even you can see the enemy count, the score BCD, player score BCD. It's a multiplayer game, so here there is a player 1 score BCD and player 2 score BCD, and the highest score of the games played in the previous. Now next, this is the button conditioner module. This module is basically used to manage the debounce of the clock pulses. Here you can see the debounce count 20 I have given for this game. Now this is the VJ Sync module. This is used to control the game on the monitor to manage the dimensions of the game in the front and even the back. Here you can see I have declared this parameter integers. So this makes sure that the pixels are clear while playing the game. Next, this is the main important module, which is game state module. This is main FSM. These lines define the state, lane to X, speed from score, interval from score, etc. Here you can see state start, it initializes the game. Next state play, this handles the movement, score, collision, and difficulty. Next one, the state turnover, switches from player to player B. Means when the lives of three players, that is the player A lives are over, then it switches to the player B. And this last one, the state game over. When both players complete their lives, then the game is over and declares the winner. Here you can see the winner done winner. If player 1 wins, then it declares winner is player A. If player 2 wins, then it declares winner is player B. Next, the enemy controller module. This module stores all enemy cards in arrays, chooses lane, selects a valid lane. That is, it always blocks active enemies move down every frame. When a car leaves the screen, pass count increases for scoring. That is, when the cars move, it increases the score of the player A or the player B. When spawn timer becomes 0, new enemy spawned with lane safety checks and a safety lane rule on the game. Here you can see the outputs of this module here. Enemy count increases when the car passes the enemy cars and vice versa. This is the collision detector module. This is also a important module for this game because it will perfectly detect the collision. Here you can see these are the dimensions of the road, lane, car. Now this is important because here if enemy gives a dash to our car, then collision occurs and the value goes to 1. So 1 denotes that a collision occurred, so 1 life is gone. Now this is a very small module binary to BCD. This is just used for calculating the scores of the game. And this is the font module to manage the font of the score and high in the game. This is the FRS module, which is used to generate random cars in the traffic so that collisions occur. And coming to the last module, this is the game renderer module. It is used to manage the colors of the car, the road, and even manage the lanes and even the screen and make sure that there is no color gradient in the game. So now you are done with the design source files. Now this is the XDC file which is known as constraint file. Now here these two lines are important because it declares the clock for the board which is 50 megahertz. This board is working on 50 megahertz. Now this next one is used to control the start, stop, right, left and the restart. And this next one is used for the VGA sync control, that is here you can see for VGA sync control. And next I'm using these pins D15, F12 for VGA red and this D16, F15, E15 for VGA green and these pins for the VGA blue so that monitor can use all RGB 3 colors. So this is the constraint file of this project. Now next I will show you how to run synthesis, run implementation and generate bitstream. So let's go ahead. Here in the left side you can see the run synthesis, run implementation and generate bitstream option. Now I will show you how to run synthesis. Click on OK. OK. Now here you can see my synthesis successfully completed. Next I will go with the run implementation option. Here even you can find the run implementation option. OK. OK. Now wait for a second. Here you can see the synthesis done complete. You can find it below and even you can find it at the right corner initial design. So it means your implementation is on the way. Now here you can see implementation successfully completed. Now next generate bitstream. Select it and click on OK. Now it will take some time, wait for the bitstream to be generated. Here you can see the implementation is complete on the right side of the screen. Now you can see running right bitstream. Now your bitstream is successfully generated. Now you can open hardware manager. Click on OK. Now next, remind me later. Now here you can find open target. Click on it. Then auto connect. Now here in the left side you will be able to see a board. So here this is our board XC7835T part number. Now program the device because it's showing it's not programmed. Now you can see your board is programmed successfully. Now we'll go for the demonstration of the game. Before I will show you the controls of the game. Now here this is how the program board look like. Now I'll be explaining you the parts. This is for these are the buttons I'm using to control the game. This center one is to start the game. The up one is to pause the game. The down one is to restart the game. And these left and right buttons I'm using to move the car left and to move the car right. And this is the board program and this is the switch to turn on and turn off the board. I hope you understood the controls. Now I'll show you how the game works on the VGA monitor. Here you can see the board is programmed. Now I'll go to the VGA monitor and show you how the game is working. From player A, player B, now I'm going to start the game. I've started. So here you can see I'm smoothly moving the car to left and right. When a dash occurs, it will show crash. And at the right corner you can see there are 3 lives. So now 1 life is reduced when I crash the car. See again life lost. So 2 lives are gone now. 1 last life is left. And at the left corner you can see my P1 score is 22. Now player 2 has started the game. Now see again. I have paused the game by pressing the up button. Life lost. I'll pause the game again. Wait. You can see it. See I have paused the game. Now I'll end the game and show you the results. Wait for a second. Crash, life lost again. Last life is left. Here you can see A wins P1 22 and P2 17. Now I'll restart the game. Here you can see the high score is above 22. So like this you can play the game continuously. So my card dodging game is successfully implemented and bitstream is generated and even the game is working perfectly on the monitor as you have seen without any errors and delays in the button and the winner is even declared at the end of the game. So now I want to continue with the second game which is Crash Ball game. Now since you already know how to create a project and how to add design sources, now I'll directly explain my design sources codes. So in this Crash Ball game, the first design source is Brick Breaker. Here in this Brick Breaker, the logic of the game is written, which is the main heart of this game. I'll be showing you the code. Here you can see this. Here I have given all if else statements for the restart and for pausing the game, etc. And here I have declared the parameters for the paddle movement, the ball speed, and even the block breaking, etc. And I have even here given the pause text, paddle control frames, and game over dead conditions. And next, the second module is clock division module. Here, our board is working on 50 megahertz and the VGN is only 25 megahertz. So to break down the frequency, we are writing this clock division code. Next, VGA sync. This code is same as the code used for the previous game. So I'm not gonna explain this again. Now next, the last one, which is the debounce code, which is used to make sure that the button reaction is sent perfectly to the board and controlled on the monitor without any delay or any error. And the final one is the constraint file. Here you can see I am using these pins for the clock signal, which I have been using even for the previous game. And next one. And even next, these are also the same as the previous game for RBG, red, green, blue colors in the VGA. And these are for the LEDs. Here I am using different number of LEDs to show how many lives are left. So overall, this is the all module codes and constraint files of this project. Now here again you should do synthesis, implementation and generate bitstream. I have directly generated bitstream for this project. As of in the previous project, I have explained how to generate bitstream and how to do implementation and synthesis. So now I will be showing you the game on the VGA monitor directly. Even the controls for this game are the same as the previous game on the VGA monitor.
Now you can see I'm starting the game. The game is started. So above you can see at the right corner there are 3 hearts, which means 3 lifelines, and a score at the left corner, which is your score, and the HI means the highest score, which is from the previous games you played when the board is programmed. So here you can see the ball went down, so 1 life is decreased. Now again I started the game. So you can see again 1 more life is gone, last life is left. Now you can see all 3 lives are gone, then game is over and your score is 140 left out. Now again I restarted the game. You can see here the highest score is 140 and again 3 lives are restored. And I have even paused the game, you can see.
So coming to the conclusion, here you can see the game is working successfully. So in this video, you got to know how to use Vivado, how to run codes in it, and how to use the RTX 7 FPGA development board, and even how to build real-time games in it. So I hope this video is helpful for you to build games in FPGA and using Vivado. Thank you.